Hey guys, I am going to be covering indicator 35 today. And indicator 35, now this is going to be unit 11, and it has indicators 35 and 36. So this is all about data displays. And in indicator 35, I will be covering line plots, histograms, and stem and leaf plot. I will show you how a data distribution is done, whether it's skewed right, left, symmetrical, whether it's unimodal, bimodal, multimodal. So you will learn all of that. And indicator 36 will be all about box and whisker plots, okay? So let's start with a line plot. But before that, let me quickly talk about the learning target. I can display data in plots and histograms, and we're talking about the line plots. Stem and leaf plots. I can calculate the number of observations in a data set. That means how many are, you're counting the frequency of people or things or items in a certain area of the graphs, and we'll discuss that in a minute. I can calculate mean, median, and mode and describe it in context. So looking at the graph, you should know where does the median fall in a histogram, for example. I can choose and defend the best measure of center to describe a data set. Is there an outlier? If there's an outlier, then mean is not a good choice. It would be median. If there is no outlier, mean would be a good choice, and things like that. I can describe the distribution of a data set in terms of center, spread, and shape, and that's what this skewed right, skewed left, symmetrical, etc. is, bell-shaped, and all that stuff. I can identify deviations from overall data patterns. Okay, so we've talked about mean deviation yesterday. I showed that to you. But that's basically what all this is about. Okay, so let's start with a line plot. In a line plot, of course, first and foremost, I have to have a line. Okay, get a better marker than this one. So first thing is, of course, I have to have a line, and you all know how to make a number line. Okay, and there it is. And then we obviously place our intervals 1, 2, 3, 4, 5, 6, 7, etc. Okay, and then a line plot is basically it uses a number line to show the number of times each value in a data set occurs, and X is placed above the number line. Okay, so I can put this. This X is telling you how many times that number is occurring. So I can say that, let's say we're talking about, well, it's too small to be a shoe size, but let's say, jeans size, for example. Okay, size 0, we have 4 people here. Size 1, there are 2 people. Size 2, there are 4 people. Size 3, there's 1. Size 4, there's 1. Size 5, there's 1. Okay, or let's just make size 1 like this. Okay, so looking at this, let's say we're talking about jean sizes over here. So make sure you label your graph so that we know what you're talking about. And so this is, you can see that there are 1, 2, 3, 4 people who wear a size 0. There are 1, 2, 3, 4, 5 that wear a size 1. There are 1, 2, 3, 4 that wear a size 2. One person wears a size 3, one person wears a size 4, one person wears a size 5. Okay, so always count how many numbers you have in the beginning, and then make sure you plot it all, because even one missing, your graph is off and it will not be counted correct. Okay, so in this I know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 people in that group who have been counted. So make sure that you are looking at this. Now, so this is what a line plot is. You make a number line, and for each thing, you are just putting an X to show the frequency of that. Frequency means how many times something occurs, okay? And then you can count all of them to know how many people are in the class, or you can count as to where would the median be. So I just counted, how many did I count? 16, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm saying 16 is the total number, okay? And where would the median fall? So median means what? The middle number, okay? So half of 16, because that's the middle, it's going to be 8. So we are going to see where is this person going to fall, okay? Or where is the median, in which category is going to fall. So 1, 2, 3, 4, 5, 6, 7, 8. So median is falling in size 1. Because if I have 8 here, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 here also. Okay, and since it is 16, we know it's an even number, so we are going to have 2 numbers in the middle, which so it would have been, in this case, it's 8 and 8, which is going to become 8 anyways. All right, so we know that the median is going to fall under size 1. All right, so make sure that you can do that just by looking at the total number of items that are over here. Okay. Now, if I look at this and I start talking about data distribution, and we ask where is the data distributed, so basically you look at the shape of the graph, okay? So you look at the shape of the graph, and then you can identify what kind of a graph it is, okay? So in this one, I can look at this graph and I'm trying to see, okay, where is the tail end of the graph? Okay, so I'm trying to see where is the tail end of the graph. So tail end of the graph meaning where is the graph being pulled at? Okay, where is the graph being pulled at? So if I look at this, I can see that if I do this, okay, compared to just this, okay, normally what you do, you look at the highest value. This is the highest value is here, okay, and then I make this like this, all right, and then you need to see that from that highest value, now this skewed right, skewed left, it also the same rule applies to a histogram, okay. So when I look at the highest part over here, and look at this part over here, this is on the left, and look at the right of all of this, this is on the right. Okay, so as you can see, the tail end is much longer over here. So this graph is skewed right. Okay, and basically when it's skewed right, we can just look at this graph and know that if it is skewed right, my mean is going to be greater than the median. Okay, so in graphs like this, the mean is greater than the median. Okay, and so this is also called positively skewed. Okay, this is also called positively skewed. All right, so let me just quickly show you the graphs before we do the others. So yes, this is skewed right. On the other hand, if I had a graph in which, let's say, the tail end was this side. Let's say my graph was something like this, okay? And this is my number line. Oh, Lord. This is my number line, for example. And I'm just going to make up something, some values over here, okay? And then we just have 1, 2. Okay, so if I look at this graph, look, the longer part, the tail end is to the left. Okay, so when this happens, this is skewed left. Okay, this is skewed left. And in this, basically, again, is going to be the absolute opposite of your skewed right. And in this, if the mean is going to be less than the median. So in this, the mean is less than the median. So the median is on the right, or greater than the median, sorry. And this is also called, since this is a positively skewed, it's not the positive side, this is skewed to the left, so this is negatively skewed. This is negatively skewed. All right, so I just want to show you what the graphs look like if you're saying positively or negatively. Positively skewed right because it's going, the tail end is to the right, and then the negative one would be going to the left. So therefore, it is negatively skewed. And in that case, it means the mean is less than the median. In this one, the mean is greater than the median, okay? Let me just show you over here. A symmetrical graph would be one. Let's say I have this, and I'm just making up again something. Look. So here's the center, and this graph is going like this. And it's identical on both sides. It's like a mirror. So then this becomes a symmetrical graph, okay? So as you can see, both sides are the same. Mean and median will be the same, all right? But most graphs are bell-shaped. I might have something, like this. So a lot of graphs are bell-shaped like this, and then in this case, the mean and median are approximately the same, all right? And then when you have one thing going up, like see one of this going up and then coming down, it is called unimodal, one mode, one high point, okay? But in a graph, if I have, you know what? I don't have time to take it over there. But I'm just going to erase this so I can show you. See, this is unimodal also. Of course, it's positively skewed. But if I had a graph that, let's say it was like this, and I'm not drawing the graph, I'm just showing you, okay? So if something goes up like this and then again up like this, this has two modes. So you might have this high over here, you might have another high point over here, okay? And then you might have 1, 2, okay, something like this. So I'm just showing you that when it has two peaks like that, it's bimodal. Most graphs have one peak area, so it's called unimodal. If it has several peaks up and down, up and down, up and down, then that is multimodal, okay? So these are a few things I just wanted to remember about graphs. Remember, skewed right, the tail end is to the right. Skewed left, tail end is to the left. And then symmetrical means both sides identical. Most graphs are normal, which is like a unimodal, one mode, and it goes up and then it comes down. Okay, that's what most graphs are like. But you can also have bimodal and multimodal graphs. Okay, so this is just showing you the distribution. Now, let's plot this line plot over here, which is telling me that ages in a school library. So as you can see, we have all these ages that are listed in the table, and we are going to make a line plot with this table, okay? So first and foremost, of course, you are going to make a line, and whenever you are doing graphing, a line is the first thing that you need to be making. All right, so remember to always label your graph. Always label your graph so that we know what you're talking about, okay? So you're going to draw a number line, as I just mentioned. And then we can start looking at what is the least value, what is the greatest value over here. So my least value, my smallest number I can see is 13. and my largest number is 24. Okay, so I'm just going to start at 13 because that's the smallest I need. So 13, 14. Now, if you're taking by twos, that's fine. Whatever interval you do, please do the same interval for in between. Okay, so but I'm doing 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and the highest I needed was 24. Even if a number, which is I put over here on the number line, is not existing here, you cannot eat up that number and make it just disappear from the number line. Okay, your intervals still have to be there and the same. You just cannot jump from this number to this number and instead of 21, you sit and write 24 over here. Cannot do that. Okay, intervals have to be the same. So now let's start plotting. Okay. So let's see my smallest. Okay, I can start with 14. So 14, I have 1. So each thing you are going ahead and doing this so that we know, and you can keep doing this while you do this so that you don't make a mistake. And I know I have 1, 2, 3, 4, 5 times 4. So I should have 20 people on this graph. Okay, so 14, then 16, then 17, then 15, then 24, see what I'm doing, 18, 15, so 18, and then I have a 15, 16, 19, I have a 16, and I have a 19, I have a 14, 13, 24, 18, 16, 15, another 15, 14, another 15, 16, and 17. All right. Now, once I have this, make sure that you count that you have the right amount of people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is correct. Okay. So this is just telling me, that this is ages of people in a school library. Okay. Ages of people in a school library. So make sure you label your graph. That is essential so we know what you're talking about. This is showing you the frequency. That means the number of people of that age that are in the library. Okay. And so if I ask you for the distribution of data over here, as I can see, it is skewed right. Okay. Because look, if I do this, oopsie, that should have been a little bit more up. It's going like this, and then it goes up again. But we don't know if it's going down. Okay? So, but if I look at this, where is the majority of it going? To the right. I can see this is skewed right. Okay, this is skewed right. Because the tail end is more on this side. Okay, it may end up, if you take more data, it might end up to be bimodal, but right now what we have, this is what we have. It is skewed right. That means your mean is greater than your median. This also means you can also look at this graph and say immediately that yes, it is skewed right because the tail end is to the right. It is positively skewed. But you can also say, looking at the group of people, that most people are what? Teenagers, right? Now, just by looking at the graph, because there are 2 people who are 24, might be the teachers. But in the school library, most of them are falling in this category from 13 to 19. So most people are teenagers over here. Okay, most people are teenagers. By looking at the graph, I can see that. All right, and or are in our teens that go to the library. But if I'm looking at the distribution, it is a skewed right graph. Okay, so just want to make sure that you understand a line plot. Now, let's talk about a histogram. Okay, so histogram is a graph, it is a bar graph, but slightly different from the bar graphs that you're used to. Okay, this bar graph, it is shown based on intervals, and there are no gaps between the bars. Can't have any gap between the bars. Okay, so let's make a histogram. Let me do one thing. I'm going to show you the difference between a bar graph and a histogram, so that you know the difference. Okay, a bar graph might be something like, let's say, I ask students in my class, what's your favorite candy out of, let's say, Twix, let's say Kit Kat, or let's say Hershey's. Okay, so I give you 3 candy bars, and then I ask you, what is your favorite? And so always remember to label what you are talking about. And here we would have students, right? Because that is telling me how many students like it. So if I say 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now let me show you what the bar graph looks like. I might have 5 students who like Twix. Okay, so I have 5 students who like Twix. You can see the 5 shows the frequency. You can write the number on the top too if you like. Okay, for Kit Kat, let's say I have 8 students who like Kit Kat. You can write 8 here if you like, but otherwise, just by looking at this, I know that this is 8. Okay, so this is 8 people who like Kit Kat. And then let's say Hershey's is liked by 6 students. Okay, Hershey's is liked by 6 students. So this is a bar graph in which you have gaps in between, and it is a really good representation of what it looks like visually when you're comparing. And to find out the mode, you can easily see that the most popular is Kit Kat. You can also see how many students there are in this class. If I'm saying, 5 people like Twix, 8 like Kit Kat, Hershey's 6 people like. So total number of students would be 5 plus 8 plus 6. And so then that is 19 students in this classroom. Okay. Now, so this is a bar graph. Okay. Histogram is slightly different. You have intervals. Okay. So let's say I give you a graph of a table, and the table is telling me the number of students who did certain number of push-ups. Okay, so I'm just going to write over here push-ups, and I'm going to write students. All right, so this is categorized in intervals. A student may have done 0 push-ups, can't do a single one, or could have done 8 push-ups, could have done 7 push-ups. So what we do is we categorize in intervals. So let's say I have 0 to 9 push-ups. If I have 10 to 19 push-ups, okay, 20 to 29. So see how my intervals are exactly the same. Okay, it's not changing. It's not 0 to 5 and then 6 to 20. You can't do that. These intervals have got to be identical. Okay, 30 to 39, and then let's do one more, which is 40 to 49. Okay, now also watch another thing what I am doing when I do the intervals, and we'll talk about that in a minute. I am not writing 0 to 10, 10 to 20, 20 to 30. I am not doing that. I'm not putting 10 in both areas. I'm not putting 20 in both areas, etc. I'm going to talk to you about why that is so important. Okay, so let's say this is 3, and then this is 5. This is 10, and then we have, let's put this as 6, and let's put the last one as 1. Okay, so once we have this done, we are going to make a histogram. Okay, so once again, it's like labeling like in a bar graph, it's slightly different. Okay, so this is the number of push-ups. Okay, number of push-ups. Remember to label your graph, that is essential. Okay, and this side is going to be the frequency, all right, or the number of students. This is the number of students. Okay, so if I'm doing the frequency, this I have 0 to 9. Okay, then I have 10 to 19, 20 to 29, 30 to 39, and 40 to 49. Okay, so for students, I am just going to write it. You can do 1, 2, 3, 4, or you can do 2, 4, 6, 8, whatever you choose. Let's say I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now from 0 to 9, you can see that your frequency is 3 students. So you make a bar graph. Now since it is 0 to 9, this bar is going to stick to the y-axis. Okay, if it was a frequency like, let's say 10 to 19, that's what the first frequency was, then it would not stick over here, because this sticking over here means 0. Okay, if it was 10 to 20, you would have had a gap over here. You would have started here. Don't stick the graph then. Okay, for 10 to 19, we have 5. So look how my graphs are stuck together. It's not separated like in this bar graph over here. That's what makes it a histogram, and the intervals. For 20 to 29 push-ups were done by 10 students. So here goes my graph, and see how it is stuck again. All right. 30 to 39 were by 6 students. So 6 students is 30 to 39, and 40 to 49 is 1 student. So here we go. All right, so now these are my bars. All right, and this is what makes a histogram different from the regular bar graph that you're used to. You are welcome even to write it over here. You have 3, you have 5, you have 10, you have 6, you have 1. Okay, so this is what makes a histogram different. First and foremost is your intervals, and also there is absolutely 0 gap between the bars. Okay, now please remember, we are not writing the intervals as, I'm going to erase this because I was just trying to show you the difference between the two. But I want to just teach you one thing about histograms. Please do not repeat the intervals. Do not do this. Okay? This is a total no-no for intervals. Because look, I forgot to put 10 to 20 in between. 10 to 20, 20 to 30. Okay, so please don't do this, because look, let's say a child, we're talking about the calculations, and we're saying a child did 10 push-ups. Okay, so if I have 10 in this interval and I have 10 in this interval, where am I going to count that child? it's going to get totally incorrect. You can't put the same child in two different intervals in two different places. Make sense? So that is why your intervals cannot overlap or repeat. Okay, so that is why we have 0 to 9, 10 to 19. It's not 0 to 10 and 10 to 20, because where would I put that child who does 10 push-ups? Either on the on this bar or this bar. We don't know. So that is why never repeat your histogram intervals. Okay, it has to be a certain interval, and you cannot repeat a number in both the intervals like that. Okay, now when I look at this graph, this is definitely unimodal, and it is a normal graph. It's a bell-shaped graph, because this is what we had talked about. Most graphs go up like this and then come down like this. Okay, now, so it's a normal graph right now. If you are asked, where would the median lie in which interval? Okay, where would a median lie? So if I'm looking at 3 plus 5, for the median I have to calculate the total number of students that are there. Okay, so I have to calculate that. So the students is determined by the frequency. Okay, so I have 3 plus 5 plus 10 plus 6 plus 1. Okay, so 3 plus 5, 8, 18, then I have 19 and 6, that gives me 25. So we have 25 students in this class. And then in order to find the median, because we're trying to see, okay, where would the median be? So it would be half of 25. You take 25, median is the middle number, right? So it's going to be the middle. So half of 25 is 12 and 5/10. Okay, because you're going to get that one number in the middle, because this is like odd number set. Get one number in the middle, so 12 and a half, which would be the 13th number. Either way, from the front or from the back. Okay, so we have 3 plus 5, which is 8. And then we have 10, which is 18. So guess what? Where is 13 and a half, 12 and a half going to fall? Somewhere here, right? Somewhere over here. So that is why the median is going to fall in the category of 20 to 29 push-ups. Okay, it's going to fall in that category of 20 to 29 push-ups. All right. So this is what a histogram is. Now, remember, the height of the bar represents the frequency of the values in the interval. Okay. And now let's do the last thing, which is a stem and leaf plot. And a stem and leaf plot is again organizing your data, and it becomes very easy to read. And basically you have the stem portion, and you have the leaf portion that is set out over here. So let me explain what that means. All right. So let me go ahead and remove this. And I'm just going to give you some random numbers over here. So now we're doing a stem and leaf plot. All right. So if I give you some random numbers, all right, so I've given you these random numbers first, okay? So the first thing you need to do is count how many numbers you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, organize numbers from least to greatest. Organize them in order. Okay, organize in the correct order. Otherwise, we are going to make mistakes. So that's the first step, and that is the rule for any kind of graphing that you do. You know, whether you're doing median or you're trying to find the mode or whatever you're trying to do when you are graphing something, it is essential that you put in the correct order. Even in histogram, if the intervals had not been given to you, just had random numbers, you would first have to put them in the correct order, and then you would make them into intervals and then solve it. Okay, so you have to organize the data. All right, so let's see, the smallest is 5, so take this off. Then I see 28. Take this off. Then I see 29. Take it off. Then I see 36. Take it off. 46 and 48. I'm going to remove this so I know what I've already used up. So that way if I make a mistake, I can always go insert a number. Then I have, let's see, I have 3 69s. You write them all the 3 times. Okay. Looking at this, you can automatically see what the mode is. Maximum mode is 69 here. Okay. Then you have 70. Then you have 72. You have 84. And you have 100. Okay, so now let's count. Do I have all the numbers? We had 13 that we said over here, right? We said we had 13 numbers, okay, or 13 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So yes, I have 13 over here also. So I'm in the right direction, okay? So I'm going to go erase this because what we're talking about now. All right. And I am going to make a stem and leaf plot. So stem, you know how you have on a tree, you have a stem and then there are several leaves. So that's exactly what we are doing here. We have the stem and we have the leaves. Okay. So in this, when you are making your stem and leaf plot, you are going to place based on the place value. Okay, that's what I was trying to say. Based on the place value, you are going to write the digits over here. So since we have 5, 28, 29, 36, so this is what I'm going to do. I'm going to put my, let's do this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and then I'm just going to make a little line like this so that you can see that it doesn't. Okay, this is just to keep you organized. Okay, so now let's make this into my table. And I should have written leaves a little closer, but that is fine. Here we go. Let me organize it a little better for you so that you can see what I'm talking about. So I have my stem, I have my leaves. Okay. So, all right. So you're going to organize something like this, and then you look at the numbers. All right. So if I have 5, guess what? This is a 5 because I have no place value before that. Okay. I don't have anything after the 1, but I do have a 28. So look, this signifies the tens. So 28, okay, 28, when I read it, that's what it is. And then 29, so 29. Don't put commas, just leave a gap. Okay, so when I'm reading this, I know there's nothing in this place value, so this is 5. There's nothing in the 10, 11, 12 category, which would have gone here, but you still have to include that in the graph. Then for 30s, I have a 36. Then I have a 46 and I have a 48. See why it is so important to put it in the correct order. I have nothing in the 50s, but I am going to leave this in the graph. I cannot miraculously make it disappear. And then I have 3 69s. So 69 once, 69 2 times, 69 3 times. Okay. Then I have a 70. Then I have a 72. I have an 84. I have nothing in the 90s. And I have a 100. Okay, so do you see how I have written it out? So once I have this, then I have to put a key, and I can use any number over here. Let's say I choose to put 46. So you can choose any number and you can write like this. This is equal to 46. So you have your key from any number on this, okay? Now, if you look at this, guys, it becomes so easy to find out what's the mode. So I can see already which number is repeated the most. 69. That is the mode. Where would the median be? Median would be halfway. Since we have 13, so half of 13, and it would be 6.5. So 1, 2, 3, 4, 5, 6 this way. 1, 2, 3, 4, 5, 6 this way. So this is the seventh number because I said 6.5, remember? And it's this thing. So 69 is going to be my median just by looking at that. If I was to calculate the mean, I would have to do 5 plus 28 plus 29 plus 36 plus 46 plus 48 plus 69 plus 69 plus 69 plus 70 plus 72 plus 84 plus 100. So you would have to add all of them and then divide it by how many there are. And we said there are 13 of them. So divide it by 13 and that would give me the mean of this. So it becomes very easy to visually look at it and calculate. But this is what a stem and leaf plot is. Okay. Anyways, before I kind of get off, I just wanted to show you really quick the different graph shapes. So hold on. I did not use that data from up there that you are seeing right now, but that is okay because I like to make up my own a lot of times, so that is perfectly fine. Okay, so let me just go ahead and quickly show you what I was talking about: bimodal and this modal and that modal. So look at this one. I just want to show you what a histogram looks like also. See, this is a symmetric histogram. If you're talking about data distribution, okay, the mean and median will be about the same or the same in this category. Don't look at the box and whisker yet because that is something we'll do tomorrow. Okay, so look, both sides in a symmetric are the same. Skewed right, see how the tail end is going this side. So that is a positively skewed graph. Okay, and then skewed left where the tail end is on the left side. That's a negatively skewed graph. Okay, so let me also show you. So this is exactly what I was talking about earlier. Look, where the mean is greater because this is longer tail, and see how long the right side is compared to the left side. Okay. Let me show you this. This is what a bimodal looks like. Okay, see, there are two modes, up and down, up and down. So therefore, this is called bimodal data. This is the histogram of that. Look, that's bimodal. Just wanted to show that to you all. Okay. This is unimodal, and that's how normally graphs are, and can't really, well, it's non-skewed, it is symmetric, it is unimodal, so this is a bar graph that I want to show you, okay? Here is an example of non-symmetric skewed right. See where the tail is going, okay? And here's another example of bimodal, up and up, okay? Normal distribution, again, it's a smooth bell-shaped one, like this, okay? That's a normal one. It represents numbers that are mostly in the middle of the data set and others trailing off, okay? So that's what a normal one is. Let me show you that. You also have, here you go. So this is the symmetric one that I was talking, okay? Symmetric, look. This is for that line plot that we had just done. This is for the histogram that we had done. You also have U-shaped, which go down and up. Okay. Again, this is skewed right, just showing you these so that you have a better idea about data distribution. So this is skewed right because the tail end will go here, tail end will go here. This is skewed left and left. Okay. And then you have the uniform ones also, which are absolutely the same. Normally, we hardly have any graphs which are like this. Okay, but still, that is, and the most common is the bell-shaped one. So I just want to show that to you also, so that you have a better idea of what I was talking about graphs and the distribution. But this is all about indicator 35. So just remember line plots where you are putting those little x's to represent the frequency on a certain number. You have histograms, which are different from the actual bar graphs that you have been doing. I mean, they are bars, but the bars are not separated, and you have intervals in between. And the stem and leaf plot is again a form of organization like this. All these make the representation of data very easy, and you can do a lot of calculations also just looking at this because the data is organized. Remember, tables and graphs, the main purpose is to organize the data so that you can read it and it's more visual, and the reading it becomes a lot easier. Okay, so that concludes our indicator 35. Have a great day.